Well, it's not just HR, it's the entire universe. People just get data and present it without giving much thought to, is the conclusions they're drawing from the data correct? Can you draw those conclusions? There's an oversimplification that people make, and it's very dangerous because when you're presenting information as a conclusion, people will take it. And very often you're drawing the wrong conclusions, even though the data is right. So there's 3 traps that I'd like to talk through. The first is the first because it sounds the best. It's the ecological fallacy. I'll explain by example what this is, the ecological fallacy. In 2004, we had the famous US election of George W. Bush against Al Gore, which George W. Bush won in some controversy. And the Republicans won all the poorest states. So of the 13 poorest states with the lowest income, the Republicans, George Bush, won those. Al Gore, the Democrats, won 11 of the 13 richest states. So you can conclude, can't you, that people that are rich vote Democrat? Because that's what the data shows, because rich states vote Democrat and poor states vote Republican. You can't. You're committing the ecological fallacy. You can't draw a conclusion about a group and apply it to an individual. There is a strong correlation between income and voting Republican. Richer people are far more likely to vote Republican at the individual level, so you can't do that. The second is confusing correlation with causation. Believe it or not, people that eat ice cream are far more likely to be eaten by a shark. Sharks love ice cream. It's proven in the stats. There is an extremely high correlation, very, very close to an R-squared of 1, of shark attacks and ice cream consumption. Obviously, biologists will tell you, marine biologists will tell you that sharks don't love people eating ice cream. There's just another correlation going on, which is weather. Warmer weather, more swimming, more ice cream. So it'd be very dangerous if you see a correlation to jump to a conclusion about causation. You have to use judgment and logic. Intuition always plays a part in reviewing numbers. The third trap is just looking at averages, not looking at the distribution of the data and drawing bad conclusions, not looking at the significance of it. A common example is looking at performance information. I will have a group with average performance higher than another group. I can't conclude that that group is performing higher than that group. So group A, say males, perform better than group B on average. So what? Can I draw that conclusion that males are performing better than females? I don't know. I have to look at the distribution of the data. A good way of looking at the distribution of the data is using visualization tools, descriptive visualization tools like the box plot. It shows 5 points. It shows my median, which is the 50%, which is very different to my average, often. The 50% point, so where do 50% of the population lie? And then 1.5 times that, so basically the extremes of that population. So I get a sense of the skewness of the group and also where the outliers are. That variability shows me a huge amount. You should also, if you're really going to draw positive conclusions, look at the significance. A really good example of this, of look median versus average, is imagine you've got a bar and let's say there are 100 people in the bar and the average income is 30,000. Bill Gates walks in. The average income will be millions. So you can then draw a conclusion, oh, that bar is extremely rich. The average income is millions. Well, you can't. There's one person, he's an outlier, it's Bill Gates. So be very careful about drawing conclusions based on averages and not looking at the distribution.